All right, looks like we are good to go. Okay, so as Kyle mentioned, we're going to discuss Ethernet monitoring unit in OnCommand Insight. Just as a brief introduction, my name is Miles Kniep. I previously was an escalation engineer with NetApp. I've been here for about 5-ish years. Generally was responsible for anything in the OnCommand product suite. For a little while dealt with the Waffle technology. Currently I'm based in Amsterdam, Netherlands, but previously worked in Wichita, Kansas. I've been on this team since March, so I'm the lucky guy that gets to be the guinea pig for new things. And I have learned that after moving, support does have the best coffee in the organization. So moving on to the agenda, we'll discuss first off what is the Ethernet monitoring unit. We'll discuss how it works, go through some of the requirements because it is a little bit specific compared to some of the other components of OCI or just any other NetApp software. We'll walk through installation and then go through a brief demo. And I'll also have some resource links for you in case you want to learn a little bit more about it. So on that note, the Ethernet monitoring unit is designed for troubleshooting NFS performance issues. Historically, you may run into issues where it's very, very difficult to identify a client that's being a bully on a particular workload, or you have a VM farm where a whole bunch of virtual machines are accessing the same export, and identifying that can be very, very difficult. You either have to go and install agents on a whole bunch of machines. You have to potentially offline certain workloads, which of course causes disruption, or you essentially iterate through various machines until you find the root cause. This is not only costly in terms of time, but also number of people you have to have involved, various resources from other departments. So looking at that, the Ethernet monitoring unit goes through and monitors NFS packets that are connecting to, sorry, one moment, I have an audio problem here. Can you hear me?
Yep, you're coming in loud and clear now.
Okay, yep. Sorry about that. Started to get a lot of beeping and feedback on my end. So essentially, moving from there, you can see how I can immediately see on an internal volume view here what clients are accessing the FlexVol. From there, it's easy to see what is the spread, which particular machine is causing the most workload. So looking at the architecture, what this requires is that you have to have span ports that are mirroring traffic from switches over to the Ethernet monitoring unit. This monitoring unit has to be a physical machine, which we'll look at here on the next slide. But in terms of looking at the web client, it looks kind of like an acquisition unit. So what it's doing, though, under the hood, I guess you could say, is that NFS packets are being examined. We're looking at the operation type. We're looking at who is the destination IP address, and we're looking at what sort of internal volumes are being addressed. One question that comes up frequently is how could you possibly monitor every single packet that's going, for example, on a very, very busy cluster? How can we see everything? Surely the ports may drop packets and things of that nature. The nice thing about Ethernet monitoring unit, though, is that we're doing a statistical analysis, so we really only need a sample set. So those span ports can be completely consumed, but we still are able to build a top list of what are the most heavily loaded volumes, and then from there determine what are our top clients or top IPs that are accessing those internal volumes. So going from there, we've collected that data on the EMU, and that gets forwarded onto the OnCommand Insight server. Since this is all integrated, it's not like a completely separate tool that we have to do a bunch of correlation on. All of that data gets fed directly into the OCI database, and we're able to basically build that into the normal OCI model. So with that in mind, you're going to be looking at only NFS v3 protocol operations, but on the internal volume page, you'll be able to see which clients are driving those operations, and then hopefully from there, be able to deduce where to move to next with regard to troubleshooting. So with regard to requirements, this is something that can only be implemented on OCI 723 or higher. You must have the Discover and Perform licenses, which that's kind of your core set for OnCommand Insight anyways. The OCI server must be monitoring the same storage array as the EMU. Otherwise, you're not able to do any sort of mapping there with regard to that. Currently, it only supports NetApp storage, so that's going to be 7 mode, cluster data ONTAP, and then, of course, ONTAP 9 and upwards. And it only supports NFS v3 traffic currently. On the network side, you do have to have ideally at least 10 gigabit Ethernet ports. You could try something smaller, I suppose, but the issue there is you'll be dropping a statistically large amount of packets, most likely, which then may not give you the best representation. We also only support IPv4 traffic. Continuing on to the requirements, platforms supported are going to be Red Hat 7.2 or CentOS 7.2. One thing I will note is that this does not mean that your OCI server must also be installed on Red Hat or CentOS. It's okay for that to be on Windows. That's not an issue. It must also be a physical server. You cannot run this on a virtual machine. While this can be, I suppose you could say, a deployment challenge, keep in mind that the potential cost of other solutions that may help identify this kind of thing are still quite a bit more expensive than the hardware that you may need for this. We can't do for encrypted traffic. That's fairly straightforward since we can't really parse encrypted data. We have to rely on the fact that unencrypted NFS is how we're going to understand that traffic. As I mentioned, there is a traffic max, but that's still statistically a large enough sample set for it to be meaningful. And essentially, you're looking at basically 1 EMU per storage cluster. And the reason for that is, again, that the span ports have to be the switches that are directly connected to the storage. And from there, so if you have 8 arrays you want to monitor, surely those are going to be different switches. And as mentioned before, since NFS v4 is not currently supported, a few things you should know is that this data is not something you can interrogate out of OCI using the REST API or building it into a performance policy or anything. It's really for when you identify a problem in the environment. This gives you a little bit more context that should help solve your time to solution in terms of troubleshooting by a pretty wide margin. So going to get the Ethernet monitoring unit is straightforward. You simply go to the download site, choose whichever version of OnCommand Insight. Note, you don't have to choose Linux. If you go to the Windows install page, as you can see up here on the right, it will still show the Ethernet monitoring unit. It will just note that you have to have a Linux image for that particular one. Procedure is fairly straightforward. Log into the box, unzip the package that you downloaded, run the install script with sudo, and then answer each of the prompts. Note, we do support jumbo frames here. And that's actually very important to designate because if you are using jumbo frames, that changes some of the behavior in terms of like buffer space that we're using for monitoring. Any questions so far before I move on to a live product?
Yeah, what would happen if if you tried to install this on a VM?
So I think the challenge that engineering had with this, I guess first let me open with a caveat here. I've not tried this myself, but I suspect that what you would run into is that because those ports may be shared, for example, the span ports, if you plug those into, say, I guess, an ESX host, and then had that data feed into the virtual machine, you may just have some conflicts that too much of the packet amount is being dropped. So what I mean is that statistically speaking, it becomes insignificant, and so we can't really rely on it.
Is there a timeline for SIS monitoring? Is that on the roadmap or?
Not to my knowledge, but I will check on that. Could you send me a message in chat so I can make a note of your name?
I will do that, thanks.
Thank you.
Also, is NFS v4 on your roadmap? Could you possibly check that?
Yes, just send me a message in chat because there's a lot of you. Thank you.
All right, thank you.
So let's look at what this looks like in OnCommand Insight. So let me just go back to dashboard here. This is just a demo box I have. Note that because this is a demo system, it is not a live Ethernet monitoring unit. We're using a snapshot of a existing environment. So if I go to admin, you just have another button, kind of like you do for acquisition units. You just have something for Ethernet monitoring units. So this one's been named Spectra unit. If I click on this guy, I'll have a history of events. Obviously, since this is frozen, I don't have anything too useful here, but generally you'll see success or connection failure, kind of like you do for data sources and the like. You can see what associated storages I may have. So there's only one currently that we're monitoring. That's NTAP Perform. And we can see here, this is a 7-mode box. That's 6200. And so on this perspective, I don't see a whole lot. This doesn't change, but as soon as I drill down to internal volumes, that's where the meat of what EMU is doing will help me identify an issue. So here I'm looking at a volume. I can see here NAS connection off to these ESX hosts. And here I can see active NFS v3 contributors. So immediately looking, I can see that there's one particular virtual machine that does about twice the amount of IOPS on this internal volume versus some of the others. Though that may or may not be an issue. I guess I do see pretty high latency here, but relatively low IOPS. So coming up here, that's a little bit surprising considering this is marked as a gold fast tier for an ERP system. So it could be that maybe this workload should be migrated. But looking at this, what I can do here is open up a chart, and we'll give you a nice representation of who's doing what. So let me pare this down here just to look at our top 2 contributors. So you can see it's a pretty wide disparity between the two. So VM9 is only doing roughly 64 IOs per second, whereas VM0 is doing something like 116. So at that point is when I would start investigating the virtual machine to see, okay, why do we have such high IO, at least relative to the other virtual machines in that environment? And maybe I could then, let's expand this guy. Look at our memory. Oh yeah. So here we can see memory is just nonstop maxed out. So I would take a guess here. If I were to go look at our swap rate, it's going to be, yep, fairly high as well. So you can see here when we have a high amount of latency in this environment, that also kind of correlates to when the swap rate is just outrageous. Of course, it seems to be fairly consistently outrageous. So I think at that point, whoever is responsible for this virtual machine needs to go look at the configuration or what application is on there. So that's kind of how the landing page would look for the EMU when I'm back over on the internal volume. Something else you might keep in mind, though, is you can also get to it from when you're looking at the application dashboard. So I don't have an anomaly detection unit on this box, but if, for example, I were to get complaints from users about a particular application causing issue, I could come over here and I could similarly look, oh, look, here's the storage resource associated. I see fairly high latency. I also see some VNs that have high latency as well. And this is just going to take us right back to the same place. Like so. So any questions about the view? Does it make sense in terms of the statistical collection, why we're not trying to collect every packet and that sort of thing? It seems to be a common theme.
That makes sense. Now, if you had to troubleshoot something a little more live, could you enable capturing every packet for a particular box, or that's where you start looking at your Ethernet guys?
Yeah, that's where you would really start looking at the Ethernet guys or that particular OS, but this helps you at the high level isolate it down to just a few potential bullies, for example, or maybe even just one bully, because at this point, even though it's very, very low amount of operations, I can still, with pretty high confidence, say, oh, look, my volume is impacted. I need to start investigating what on earth VM0 is doing.
Makes sense.
Yep. Outside of that, there is a fair bit of documentation on the new document center I would make note of with regards to workflow and configuration. Looking at resources, here are some links. I'll, of course, send out these slides to all of you that are in attendance. Any other questions? Okay. Well, thank you guys for the time today. I know it was short, but I think it's pretty straightforward at a high level at least. If you do have questions, feel free to email myself. That's just miles.kniep@nep.com or Kyle.
Cool. Thank you.
Thank you.
Hey, thank you guys for showing up. And as usual, we're always looking for feedback. So if you guys like this presentation, go ahead, shoot us an email, let us know if there's anything that you felt like was left out, or if there's any particular webinars you guys are looking for us to build. Please reach out to us, let us know. We're happy to get these things built out. And thank you, Miles, for running through that. Have a good day, guys.
Thank you.